Thanks. Hello, everyone. I'm Tambet, and my presentation today is titled "When we can expect robotaxis in Tartu." That's the question that everybody asks me. Oh, you, Tambet, you are working on autonomous driving. You must know when the self-driving cars will be on the streets when they come in the Tartu. So please tell us. And I get this question so many times that I decided that I do a presentation about it, because those simple questions like that, they usually don't have simple answers. So maybe this presentation will answer some questions, but hopefully it will also raise more questions for you. So, but before we start with Tartu, I wanted to ask more general questions. When will be the robotaxis on our streets? And this is a simpler question, because the vastus is, they're already there. In San Francisco, there are at least 2 companies actually offering public service to people with driverless robot taxis. Here are my words, driverless, like there is actually nobody behind the driver steering wheel. And there are some differences in the operating area. For example, Waymo, which is the former Google car. This darker blue is the area available for everyone, and this lighter blue is only for employees and guests. And for Cruise, it's slightly different. They have a different service area at nighttime and daytime. So at nighttime, actually, it's easier for the self-driving car, because LiDAR doesn't care if it's daytime or nighttime. The traffic, there is much less traffic in the night, so the service area at night is bigger. These are actually outdated figures. Just a few days ago, both received a permit from the city of San Francisco to operate 24/7 everywhere. So this is happening as we speak. Everything is changing, but yeah. For the sake of the story, I'm showing these images. So they're already there. So what is the user experience? What people tell? I haven't been there myself, but I've been reading the experiences that people share on the Twitter. In general, they are positive. They say it feels safe. Quite often they say that it feels human-like. When it overtook some cyclists or handled some weird situation, they say it felt surprisingly human. And they tend to handle most situations well. For example, somebody runs on your way, they brake, they don't brake too much, they handle the parking cars, they overtake them. They are pretty good. But there are issues. People say that they tend to be slower than human drivers. So when you are rushing to airport, maybe taking the self-driving taxi is not your first choice. Also, they take longer routes, because the longer routes, they choose the routes which are safer. There is less traffic, or just less left turns or something. So they tend to take longer routes, which makes it also slower. They do not drive everywhere. Sometimes you have to walk a couple of blocks to get to the road that is mapped for the self-driving taxi. And they always don't stop where you expect them. So when you stand at the side of the road, normal taxi driver would see you, like a single person with lost eyes, but the self-driving car doesn't do this, and it just stops wherever it sees there is a sufficient space. But still, this is one example from a person that said that the future is here. These self-driving taxis actually operating on the streets. So these were like a user-level issues. Now we get to the city-level issues. The situation is slightly more grim here. What people complain is that those taxis Sometimes, it doesn't have to happen too often, but sometimes they stop in unexpected places and block the traffic. In the worst case, they block the traffic for emergency vehicles, like when somebody has a medical emergency and they cannot be taken to a hospital because the self-driving car was blocking the way, then that could be like a life or death question. Also, they sometimes run into construction sites. They run into the areas surrounded by the police do not cross tape. I think there was a video where it kind of ran into the crime scene and nobody was able to do anything. And people try to stop them. Like there are videos. This is a frame from a video where the fireman wants to stop the self-driving car. It shouts to stop self-driving car, stop there where you are. But of course, self-driving car doesn't react. So there are also hilarious videos where the policemen try to stop the self-driving car. The self-driving car, for some reason, stops. They walk next to it, knock on the window, and ask it to let the window down. And then they see, oh, there is no one. And then the car starts driving again, and this policeman runs chasing it, and so on. To some extent, these are funny, but if it happens with an emergency vehicle, or when you block some way for the emergency vehicle, this could be like a life or death question. And there have been occasional fleet-level failures, so that not just the single cars park in a wrong place, but there is a congestion of, like a traffic jam of multiple self-driving cars stopping in the same place at the same intersection, blocking the whole traffic in this area. It doesn't happen too often, but I remember at least 2 occasions with crews. The last one was like 2 days ago. There was some large festival, how they explained it in the Twitter, and there were some bandwidth limitations. So they need some kind of communication with the mothership, and if this communication bandwidth is not like large enough, big enough, then this can be halting the whole fleet. These things still happen, and people are not happy about it. And so the citizens of San Francisco strike back. Berlin, can I please ask you to play the video? So this is one video of people.
All over SF. These companies promise their cars will reduce traffic and collisions, but instead they block buses, emergency vehicles, and everyday traffic. They've even unallowed a person and a dog. And they're partnering with police to report everyone all the time without anyone's consent. And most importantly, they require streets that are designed for cars, not people or transit. They exist only for profit-driven car companies to stay dominant and make it harder for transit to stay afloat. But we can do something about it. First, find a cone. They're everywhere. Then gently place it on the car's hood. Make sure their car is empty. And repeat. It's really fun and anyone can do it.
Basically, these are the citizens of San Francisco revolting against self-driving car, and doing this by paralyzing the self-driving car by putting the cone on the hood of the car. I don't think it took off really, this thing. It was like in the news for a couple of weeks, but I don't remember seeing on Twitter like many videos of many people doing this. But there are many people who are not happy with the self-driving cars, and one of the reasons is actually justified, that they still make the city to be built for the cars. They're still cars, even when they are self-driving. So how can we make cities so that they are built for people rather than the cars? Okay. Still, regardless of those backlashes, Waymo and Cruise are both expanding rapidly, especially in recent weeks. I think I counted the cities the Cruise announced in last weeks or month or so. There were like 6 different cities where they are testing right now. Waymo, which is a slightly older company, started in Phoenix and then moved to San Francisco, and they said that the next place will be Austin for them. But there's a big question, like people have, or investment companies have put billions into those companies. Like the money that went into Waymo or Cruise is enormous. And it all works with the promise that this will be earned back when this technology actually works. And when we look at the map, then this is one map that very well explains why it's still a question mark. This was the Waymo service area in one of the first slides. And this is the area where the Uber and Lyft earn the most money, or where they make most drives. You see that current generation of self-driving cars, they tend to be pretty well in low traffic intensity areas. But we are not so sure about them yet in high traffic density areas. And the high traffic density areas are those places where you make most of the money. And now the question is, are these Cruise and Waymo ever going to make the money back that the investors put into them? If they can only, they have demonstrated very impressive self-driving capabilities. They actually removed the driver from the car. But if they can do it only in low traffic areas, then it's unclear if it's actually useful. Like the most profitable area for a taxi is like the bar district in downtown, where people are drunk and behave erratically and unpredictably, and that's the place where you make most of the money, and that's the place that is the hardest for the self-driving car to handle. And some people here might say that, oh, you didn't say anything about Tesla. Tesla is supposed to be like the leader in self-driving. What do you have against Tesla? Unfortunately, Tesla can be considered only advanced driver assistance, which means that in Tesla, you always have to pay attention as a driver and be able to take over control of the car at any moment. And this is called level 2 self-driving, and this is what Tesla reports to the authorities. We are level 2 self-driving. But to the marketing, to the customers, they say, oh, we are full self-driving. So there is a discrepancy between the messages that go to authorities and go to the customers. And this is a problem, and they are facing some legal issues in US right now. And because Tesla is reporting itself as level 2 self-driving, they don't have to publish their disengagement statistics. Disengagement statistic is when a person who is supervising the self-driving car takes over the control. And usually the state of California requires all the car companies or self-driving car companies who are operating on the streets to report the number of miles they were driving in autonomous mode and how many disengagements they had. And from that, you can calculate the average distance between disengagements. And Tesla doesn't publish that because they are level 2, they are not level 4. This kind of statistic is only required for level 4 vehicles. But luckily, we have some people from the Tesla community that were manually collecting this data, just reviewing, recording the videos of their drives, manually entering this data to some website. And this is a graph from this community website. And on the x-axis, what you see here are the full self-driving beta software version numbers. So to the right are the newer software. And what we really see is that, firstly, the magnitude, rough magnitude of the number of miles between these engagements is at the level of hundreds. The one line is in the city, the other one is on the highway. This is one magnitude, at least one magnitude less than Waymo here, which is 18,000. And almost 2 magnitudes less than Cruise, which is 90,000. So it's operating in a completely different league than Waymo and Cruise. Secondly, what we also see is that there doesn't seem to be much improvement over time. You would expect that Tesla has a fleet of cars, and all these cars send the data to the mothership, and this mothership trains a new model and propagates it back to all the vehicles, and this is so-called data wheel that keeps improving your system all the time. And for some reason, it doesn't seem to be happening. I don't know why. So far it seems that the scale is not all you need. Or at least if there is one car company that took the machine learning seriously and put effort into it, hired the best people, invented their own inference chip in the car, built their own training cluster, so on, and this is Tesla. And who has the most biggest number of cars, has the most data, it doesn't seem to be helping them somehow. We all hope that the scale will solve everything, but so far it seems that it doesn't. Anyway, now I would like to move on to the robotaxis in Tartu, but does anybody have any questions? The material so far? Yes? But the microphone? Can somebody pass the microphone?
Hello. Thank you for the presentation. A question. Do I understand correctly that most of the robotaxi companies right now operating through the weather conditions, in the sense of being at south and so forth?
That's true. That's true. Like that's one of the reasons why people started from Phoenix, Arizona, because it's dry and sunny weather basically all the time. In San Francisco, you also get fog, rain occasionally. So I don't think it's quite the same. But yes, no snow, no icy roads, nothing like that yet. Any other questions?
Somehow it seems to me that the long distance would be kind of more interesting use case in the way that it frees up the driver, especially in the trucking. Of course, the long distance is the problem, not the local maneuvering.
Yes, and there is some truth to that. Because many companies, for example, Aurora, have pivoted to be in the trucking business. But we haven't seen many real-world examples yet, or actual deployments. And possibly it's because the risks are also higher, like the vehicles weights more, it's bigger, the speeds are bigger, so if something happens, it's really, really bad. And I don't know the good good reason, but I guess that could be one of the reasons that why we are not seeing any deployments there. Yes, let's take one more and then I will continue.
Okay, the main problem, I understood that the taxis are too slow. Do you know what's the main bottleneck, why they are slow?
I think they are just cautious. Like they are just cautious, like when you go slow, you can brake faster, your braking distance is shorter, and you don't have to make that much prediction into the future, what is going to happen into the future, because you can stop in a very short time. And yeah, you just want to be really sure. For example, when we had the Starship robots and they were trying to cross the road, they were waiting like forever there, just to wait for the moment where everything is completely safe. And I guess it's the same with those self-driving cars in San Francisco, that they are leaning towards being safe rather than being on time. Anyway, now I would like to switch gears. Okay, that's all good. This is happening in San Francisco. When we can have something like this in Tartu? And at the moment, I believe that even in San Francisco suburbs, it's maybe not profitable enough for the Waymo. So Tartu definitely is not going to be profitable enough, and they don't need. Maybe they at some point need a like European showcase, but they have enough like potential in US and in other places that I don't think we are going to have a Waymo and Cruise in Tartu. So whatever gets deployed in Tartu, I believe that it has to be much simpler. It must be simpler to set up, easier to maintain, and it should be understandable to mere mortals, not just like the top PhDs from Stanford. Like the local person has to fix the car if it doesn't handle certain situation, some intersection, or and fine-tuning some neural network and praying that this fine-tuning didn't spoil its behavior in some other cases. That doesn't seem like a viable solution. So what I'm introducing today is a new kind of vehicle. So I'm proposing a new kind of vehicle, and I'm calling it Traxi. It's a combination of a tram and taxi, because to some extent it has the qualities of tram and the qualities of taxi. It's limited in a way, like tram is limited. It's driving only in certain on certain virtual tracks and in only certain area. But it's also taxi in the sense that it can drive from any point A to point B. And how it's doing that? So what I'm imagining is a map which encodes all the possible paths on the intersections. This is Riia-Turu intersection, and it just drives those lines here can be considered like virtual rails. And so it's a tram that travels along virtual rails. The good thing about virtual rails is that you can reorganize them at any time. You can rewire them without doing any physical work. And you would think that, oh, that seems really complicated to create that kind of map. I think there is a hope that you can create those maps semi-automatically. If you install, like on a fleet of taxis, like Bolt taxis, more precise GPS receivers which are available today, the RTK GPS receivers, I think you can create this road network, this lane network semi-automatically. Even more, you can make it part of the whole process. For example, if a person orders a taxi to a new place, then the first time the normal taxi driver drives there, maybe a couple of times, 3 times. Then these trajectories are recorded and included in the map. Once they are included in the map, then when this person orders the taxi next time, the self-driving car drives there, but now with a safety driver. If the safety driver has to take over, then some map needs fixing or something about the car needs fixing. But if you, let's say, the self-driving car with the safety driver was able to drive this route, let's say 10 times without any disengagements, the next time you send a self-driving car without a safety driver. And so the map is kind of organically growing and all the time. And you would think also that, that's so old school that we need those maps, that can't the car just figure out by itself where it can drive? And we dream of that. That's the AI dream. But I feel that we are not there yet. And at this point, the feeling of control that you have, that the way you draw the line, the way the car drives. And that's understandable for a normal person. So if a normal City of Tartu employee needs to rearrange the self-driving vehicle routes a little bit, they can do it on the map, and I think this is understandable to them. Rather than training neural network, it's just praying that all goes well. The next thing, how this thing is limited, is that it only stops in predetermined points, and this could be commonly the bus stops. The bus stops have been already planned by the city. They are in everywhere, trying to accommodate as many people as possible. And the good thing about bus stops is that they are always empty. There is nobody parking there. Parking is forbidden there. So you can always rely on them, and people know them, and they know where to go to have picked up by the taxi. And then, again, we introduced some limitations to make it easier to adopt and make it simpler. Those taxis, they would drive on bus lanes, like the lanes for the public transportation. And what's, again, good thing about bus lanes is that these are guaranteed to be empty, or somewhat guaranteed. There is, parking is forbidden on the bus lanes. And of course, there are not bus lanes everywhere, but this is Tallinn. Yeah. So there are actually existing bus lanes already that it could make use of, and it would make the self-driving task simpler. So to remind you, we want a simpler thing so that we don't have to put billions into this thing and still make it working. And it might have some priorities on the intersections, the way how tram has. The logic here is that the vehicle with the least maneuverability has the highest priority, and it has less maneuverability, the same way how tram has a very little maneuverability. And for the obstacles, it just stops for the obstacles. Whatever, if it cannot drive forward, it just stops. It doesn't do anything fancy. And then if it stops too long, let's say 1 minute, then it alerts the operator, and the teleoperator takes over and rescues the car from the situation. Of course, it's prone to many issues. It could get stuck in weird places and could block the emergency vehicles. But that's the solution I think Waymo and Cruise use at the moment as well. And of course, that doesn't mean that it never drives around obstacles. So maybe it can deviate from its path a little bit to drive around the parked cars or so. But roughly, it stays on its track. And it uses teleoperation as a fallback. So when it gets stuck in somewhere, maybe there is a roadworks, maybe there is an accident or something, then it calls the teleoperator, and teleoperator rescues it. And what the teleoperator can do as part of this is mark this section of the road as inaccessible. So all of the fleet is now rerouted past this place using some other roads in the road network. So I can imagine this being quite self-organizing or fixing itself. And at some point, like a vehicle with a real human driver is sent to this place again. And if the real human driver validates that this section is fine again, then it's included in the road network again. And so some use cases. So this is a limited self-driving functionality. It's not full self-driving car. It's a taxi, tram plus taxi. But we still believe that it gives some value to some people. And for example, some use cases we have in mind is night transport, where people want to get home from a pub or something. And nighttime, as I said, for LiDAR, it's not a problem at all. Also, there is less traffic, so there is less risk. Also, on-demand transport in low population areas. We have done some pilot projects in that. But also, I wouldn't discard like a package delivery like Clevon, the rental car, fleet balancing like Elmo or Bolt Drive, or rental car delivery like Bolt Drive. Some ideas of this can be used there. But the key idea here is that what is often said that the self-driving cars are for the last mile. I don't think it's a good idea. I think the self-driving cars should be driving in autonomous mode most miles. So most of your miles should be autonomous. And maybe the last mile is done using teleoperation. Maybe you drive into somebody's backyard that is done using teleoperation. But most miles on the magistrals, on the cities, those should be done in autonomous mode. And the very key challenge, what I see, is to never ever drive into an obstacle. And the idea here is that whatever happens, like let's say your lane network is wrong, or you have a unexpected obstacle, or roadworks, or something else. The worst thing that can happen, you stop and do nothing. And this is actually pretty challenging for speeds over 25 kilometers per hour. Like up to 20-25, you can stop in a relatively short time, so that the braking distance is not too long, so you can rely just on detection. Are there any obstacles on my way? But if you go faster than 25 kilometers per hour, then you need to also account for prediction, how those people or other cars are going to behave in future, because I cannot stop instantly. Yeah, that's challenging, and it's slightly easier with no passengers when you are delivering packages or balancing the rental fleet. Okay, and you also need redundancy in sensors. You need to have a LiDAR in addition to camera, because the camera and radar alone cannot provide you enough redundancy. And maybe the idea here is that if your sensor has a like 1% probability of failure, and the other sensor also has 1% of probability of failure, then if they are kind of independent sources of failure, you can just multiply the probability of errors. If it's independent, you can just multiply, and voila, you get the 0.01 probability of error. But if you don't have different sensors, if they are the same kind of sensors, there are just more of them, they are not independent, they are having the same kind of errors. And so it's hard to drive the probability of error down if they are the same kind of errors. Also, you need redundancy in compute, in power systems, basically the aviation level redundancy. And I'm not even talking about the software validation, which is a beast by itself, especially the validating the machine learning models. But just what I said previously, that having machine learning model with 1% probability, error probability, and the other machine learning model with 1% error probability, if these are independent models, then you can multiply those error probabilities. But the question is, how do you make them independent? If they are operating on different sensors, then you can make them independent. But if they are operating on the same sensor, then it's much harder to make them independent. Anyway, to finish, truth is that I don't know when the true self-driving cars will be in Tartu, but I hope that we will be able to see a taxi in Tartu in the next 5 years, because it's simpler and more efficient way to do the autonomy.
There are
Okay.
no flights from there.
Anyway, that's all from me. Thanks. I'm sorry for running over a little bit.
If you're already looking or thinking about the tram, why does it need to be a car? Because cars make cities worse. Why couldn't it be a bus?
That's a very reasonable question. It probably should be a bus, a shuttle type of bus. It's just prototyping is easier with cars.
And we have the company in Estonia that does this bus.
Yes.
Question, Tambet, thank you very much for your presentation. And I listened to an interview. Elon Musk was explaining that they are opting out from all sorts of sensors like radio frequency radar off, ultrasound off, and even LiDAR. They opted out. And the philosophy behind this was that, as he explained, that if a human being is able to drive just by visual sensor reception, so should also the machine be able to drive. And you said that you need to have a LiDAR. So is this the reason why the Tesla is unable to deliver a driverless car, or what is your comment on that?
Partly. I think the main reason is that Tesla is doing consumer cars and the other companies are doing taxis. That's a completely different business model. Like Tesla is asking $10,000, something in this range, for the self-driving capability. That's hardly the cost of the sensor set of the true self-driving cars. And it doesn't account for even the software development costs. And the problem is that if you would make this cost to be 20,000, like nobody would buy your Tesla. But for a self-driving taxi, you can make the sensors cost even 50,000, 100,000. And it's still cost effective, because if you can remove the human driver, then it pays off the human driver's salary in a couple of years. So I think it's a business model question, and that's why Elon Musk is forced to do the decisions it makes. And it made a valid bet. Indeed, humans can drive with stereo vision, and we are making very good progress with deep learning and AI, and maybe we will figure it out by the time we need to. But so far it seems it's a little bit more complicated, and we need to resort back to the old school robotics methods.
Thank you, and good luck with taxi.
Have you analyzed the business model? How expensive sensor sets and kits on the car can you afford to be still cost effective in Tartu taxi idea?
Like just like back of the napkin level. So in my mind, like 50,000 is this kind of sensor set that
Maximum, yeah.
Yeah.
And that is the cost of a driver for a year?
I think so. I think that I would expect the driver cost to be slightly less, like maybe 25,000 or so.
But one car is shared multiple drivers in taxis, I think.
Possibly, that's true, that's true. But also, this is only the sensor cost. You would need to add also the software development cost.
I think maybe it's not even it should maybe not even be the main goal to have a private company taxi or taxi service. I mean, in many countries you have buses driving around at night or in rural areas that are kind of taxis. Basically, you call them instead of having a bus running there regularly. And it could be done by the public service in a way, and there might be a loss, financial loss, but it is a service to the public. So I think there's not even a need to think of a business model that is only suitable for private companies who want to make money, right? Because public transport is a loss business.
Even if it's paid by government, I think they are still looking for options to make it cheaper.
No, I understand that, but I mean, maybe there's something in between, right? So that you really can argue that, okay, so the people are getting older, you know, rural areas, there's no bus service regularly because it's too expensive, but you might still have then cars driving there automatically, and they might not make money, but they serve the public, right? And I think that's a good model to pursue also.
But he did in this Tartu Nõude transport. You did not explain this experiment that you were partnering, Nõude transport.
Yes, we did an experiment in on-demand transportation in Tartu, where we gave rides, autonomous rides, to like 30 people in the low population density areas near Tartu. And yes, that was like the first validation of our system. There is a question there.
I have two questions about safety of the cars. The first one is related to the speed. So you mentioned 25 kilometers per hour, and do you know this Waymo and Cruise, what is the average speed in which they are driving currently?
I think I vaguely remember Cruise being limited to 40 miles per hour.
Which is in kilometers?
So it's 60. And let's say Waymo being limited to 90 kilometers per hour or something. So they do definitely bigger than that, and they can do bigger than that because they have a pretty good prediction models. They can predict what is going to happen in future, and they need to see sufficiently far ahead. They need to have sensors that see sufficiently far ahead.
And the second question is relating to accidents, because if they are driving is 90 kilometers per hour, and they remember a few years ago there were a few incidents relating to like human incidents. How is the situation now? Have there been any incidents, accidents involving other cars or humans, pedestrians, and how they are solved and regulated overall?
I think the sentiment, so the most well-known accident was the Uber self-driving vehicle killing a woman. And in that case, the detection system was confused about if this woman was pushing a bike next to it, so if it's a bike or a person. And so the confusion resulted in like misdetection or a misprediction of its future behavior, let's say. But I think the current consensus is that it's not that self-driving vehicles will never make mistakes. The question is, can they make fewer mistakes than humans? And so they will make some mistakes, and we analyze those mistakes, and we learn from those mistakes, but hopefully there are less mistakes than with humans. And both Tesla, Waymo, and Cruise, they have all published reports where they say that their car has less accidents than a human, like within 100,000 miles or something. But there's always a caveat. So what I've seen is that even though the total number of accidents is less, the number of rear end, so somebody drives into you from back. The amount of such accidents has gone up, actually, is bigger for the self-driving vehicles. So that's the most common failure mode of the self-driving vehicle is phantom braking, that it brakes for something, because they are tuned to be very safe and cautious, so they try to brake for anything they see. And sometimes they see just coast, and then somebody rear ends you.
What about the insurance costs for those cars? Are they higher or lower than for human drivers?
Actually, I don't know. I don't know at the moment. I'm not even sure. I don't think in Estonia anyone would. Okay, we have insurance for our car, but
company attitude would reveal how much they trust in it, right?
indeed. But I don't have a data about this at the moment.
Okay, no questions. I will be cautious about your personal road safety, I think, or was it that there was a paper bag? Sorry, no road safety for you with no reflector bag, but you know that where you can get them, right?
Okay, thank you.